we now want to look at what we can get out of Excel. Now, many of you have already used a fair bit of Excel in previous units. What I'm going to do now is go over some of the built-in functions that can be quite useful, and we're also going to introduce the notion of growth. This will be a useful review exercise for many of you, and for some it might introduce you to a few new tips and tricks. I do recommend that you work through with me as I go through this demonstration, so build it in your own Excel spreadsheet. Also, and it's one of the things that you're probably going to get sick of me telling you, is to practice on your own financial calculators the exercises, the calculations that we're doing here. A good way to do that is to print out a blank spreadsheet, or even just use a blank sheet of paper if you like. For those of you who are very neat and tidy, you may want to invest in the type of exercise book that you would have used at school, with the not graph paper, but the checked paper that you use for mathematical exercises. A lot of high schoolers remember that kind of exercise book. You can get them from stationery suppliers and so on, and they're useful when you're doing complex math. So even though you might be a long way away from school, go down to the supermarket or the stationer and grab yourself one of those. They just tend to keep your maths a little bit tidier, if tidiness is important to you. One way or another though, practice. Apply time to these things, because really that's what's going to get you through and develop these activities for the rest of your professional life. If you simply watch me do it and then go off and watch The Simpsons or something, or have a beer, that's all a bit of fun, but it won't help you get through the exams, where you're going to have to be up to speed with your calculator, or for that matter in professional practice, where the boss is going to expect you to be able to whip out a calculator and do a lot of these things pretty swiftly. Now, we're at university, so you'll notice that we don't sit down and hold your hand and take you through the calculator. If you want to get a bit of background in using financial calculators and so on, you'll find there's some demonstrations in the Property Gateway. But largely, we leave that technical side, which after all is really the starting level, the O level, to you by your calculator. Work through its instruction manual, hopefully with a background of an understanding of financial mathematics. You'll also find, depending on the calculator, there's a lot on YouTube. And so again, if you need that extra work, go to YouTube. Wonderful amount of free material there, and spend the time. And spending the time is really the important thing. One of the problems with financial calculators is there's so many different types of them. Even particular manufacturers sometimes have more than one model which operate in completely different ways. So it's just about impossible to take you through the how to do it with that. However, if you start with the simple calculations and practice, preferably in parallel to doing the Excel exercises, you'll find you'll get proficient. I would like you to be as proficient at using your financial calculator, your own financial calculator, as you are at probably riding a bicycle, or maybe driving a car. You don't think very much about putting the blinker on in the car. You've done it so many times. That's really, really easy. Right? The same with riding a bicycle. And that's how you get the skills with your financial calculators. While most of the work we're going to be doing is on Excel, Excel suits the more complex models and the situation where you want to keep records and so on. And so you've got to be on top of that. But you never get away from the need to be able to use your financial calculator. And the financial calculator, like riding a bike, is just a matter of practice. Okay, so let's get into a review of what Excel can do for us. We're going to look at the question of growth, and remember to have that pad of paper or your squared paper exercise book next to you and practice it with your financial calculator as well. If at very least, one of the good things about using the financial calculator to parallel your Excel exercises is that inside your brain, it actually helps you to kind of link how these things are working. And so it really helps your learning. And so if you think, oh, I never use a calculator at work and whatever, or I'll leave buying the calculator until the week before the exams or something, don't do it. Okay? Get in and spend the time now, because you really will find it so much easier further on down the track. And I want you to come away as really clever property people who can really impress the boss, and that'll help you with your career and getting pay rises and all sorts of stuff. So enjoy the work, do the exercise and spend the time, and just now we'll go through the exercises we have in front of us.
We've already seen that the simple capitalisation approach gives us a very simple but precise calculation for working out the value of an investment property from the example that we've been working through. We've seen that capitalisation is a special form of discounted cash flow valuation, and when we approximated it using 99 years of discounting, we're able to find that we are able to get to pretty close to the same number. However, by incorporating a notional sale into our calculation, we're able to get exactly the precise result. Now, this third calculation tends to be what we're going to be spending most of our time with, looking at how we use discounted cash flow methods, analysis, to be able to get as precise a valuation as possible, especially in more complex situations than really suit simple capitalisation. There are a couple of wrinkles, though, that we need to look into a little bit further. First of all, you can see at a glance that if I try doing my modelling over 99 years, I have a very long cash flow model. If we look at this, it goes out and out and out and so on, which is very cumbersome. We don't really need to be able to have each one of those. We're not interested in what happens at year 54 and 87 and so on. We simply really want to see how they come down to giving us a total net present value. Even when we have a more compact approach, which is done in this 10-year model, it's still, those intermediate years aren't giving us a great deal of information. And in fact, because of the regularity basically built into the calculations, they're not giving us anything which is that interesting at all. It turns out there's a simpler and faster way to basically do all of the calculations in this panel, all using a single Excel function. And this is the Excel PV function. I'm going to show you now how to use the net present value calculation to give us a present value without having to do the year-by-year calculations. And this is using the PV function in Excel. So I go equals PV, open brackets, and you'll notice that the PV function immediately comes up and it suggests that I'm going to be inserting a number of parameters. The parameters are the variables which drive the function. The first one is the rate. Here I have 15%, so I'll take that, C6, and a comma. Next is the number of periods. Here I'm going to be looking at 10 years, so I take that, again with a comma. The third is the payment, which is the annual cash flow. In this case, in a property case, it's going to be the net annual rent, which I am, for the present, assuming happens at the end of each year. Now I can actually stop there and do my calculation. In fact, I'm going to do that just to demonstrate what happens. Hit return. I'm going to size that so I can see. Now immediately you see a very strange result. We've got minus $50,000. The number is negative simply because the payment is positive, and it's normally assumed that if I'm going to be receiving an amount of money next year and possibly the year after and the year after as an annuity, I'm going to have to pay for that positive cash flow with some negative cost. And so the PV function automatically puts a negative result into its calculations for the cash flows. I can either use a negative sign, a minus sign, on the payment, or I can more easily simply put a minus sign to negate the whole PV function. And there's nothing wrong with putting that negation at the beginning. It doesn't mean that I've done anything wrong and I'm fudging. It is consistent with the logic of the way that these cash flow calculations work, and if you turn that over in your mind, that will probably become apparent. Now, one thing you can do now is, because this function is dependent on the number of years, currently I'm saying the value is $50,000. Really, that $50,000 is the value of the 10 years of net rents. We've had 10 years at 10,000, so that's actually $100,000 that's come into our pockets. But because of the effect of discounting, that $100,000 is worth considerably less. In this case, only $50,000. If I was to take a different length of time, let's say 20 years, we will see that the $50,000 will be a bit different. It's raising somewhat. If I go up to 50 years, it comes up higher. And as this number of years gets larger, you'll notice that the valuation that we get approaches the value that we get by capitalisation. I'm going to put 99 years into this calculation, and now we have 66,666 and 60 cents. Getting very close. Okay, I'll go back to my 10 years now. So that's the present value. What that's really doing is taking the number of payments, assuming a particular number of them off in the future. I'll just put, okay, by the time I get to a very large number of years, I'm getting a result which is equal to my capitalisation value. However, we don't normally do our discounted cash flow valuations over 999 years. I'm going to go back to 10. Now remember, when we looked at the problem of needing to have all of the values off into perpetuity included in my discounted cash flow, we came up with the idea of using a notional sale. I'm going to put the notional sale into the Excel function. I'm going to come back up into the formula bar, click in there just before the last bracket, and you'll notice that Excel is saying I'm using the PV function, and I'm in the part of the PV function where I normally enter the payment. After the payment, I have the optional ability to include or add the future value. That's the notional sale. And so I'm going to do that now. I'll put comma in to say I'm getting to the next parameter. I'm going to come down and grab the notional sale, and then we're going to accept that. Bingo. We have the net present value as we get it from the capitalisation, and also from our full 10-year cash flow that included the notional sale. Okay, what's the take home from that? Very simply, I can use a simple single Excel function, the PV function, to be able to take the key parameters, the key variables, and work out a discounted cash flow result without having to go to all of the trouble and bother of working out the year-by-year calculations. I recommend that you get familiar with using this Excel function, because as you get familiar with it, you'll find that you'll get to the point where you won't bother calculating the year-by-year calculations. The other place where this is useful is that as you check your work with a financial calculator, and I rather hope you check all of your calculations with a financial calculator, you'll find that financial calculator also uses this kind of logic. You'll find on a financial calculator there will be a button for the rate, usually denoted I. There will be a button for the number of periods, which is N, the button for the payment, which is usually PMT, and then two other buttons, one for the end future value, the FV button, and the last one is the PV button, which denotes the value today. And I recommend that you go into the instructions for your financial calculator to learn how to use those 5 buttons to do the calculations that we've just done here on the screen. Very important, because you'll need to be able to do that in the exam.